Alright, welcome back. We're talking about Chapter 2. We're going to be talking about analyzing data. This chapter is all about the math, and we're going to use it. So if you get confused on math, make sure that you come back to this. These videos, they're going to be really helpful as we go throughout the school year this year. So, first off, in the United States, we use what is called the imperial system of measurement. So that's where we talk about pounds, that's where we talk about miles, that's where we talk about feet, where we talk about inches. Most of the world uses what's called the System International de Units, or the SI system. And this is going to be an internationally agreed upon system of measurements. So, when we are talking about measurement in science, we are going to be using the SI system. So we're going to go over this. You've heard of the SI system before. It has meters, grams, liters, anything on the metric system. So the metric system is based on what are called base units. And a base unit is a defined unit in a system of measurement. It is based on an object or event in the physical world and is independent of other units. So what that means is there is a physical, tangible something in the world, and we have, as a scientific community, international scientific community, have chosen to base units on this thing. So the base unit for time is a second. When we're measuring time, most of the time we measure time in minutes or in hours, but scientifically you're going to measure things in seconds. Length is in meters. Mass is in kilograms, not grams. That tends to confuse people, but the base unit for mass is in kilograms. And temperature is Kelvin. We're going to talk about Kelvin a lot more in Chapter 13. In America, we use Fahrenheit. In Europe and most of the world, they use Celsius. But scientifically, Kelvin is a more perfect scale, and we'll talk about that later in Chapter 13. And amount of a substance, we'll talk about moles in Chapter 10. And then amperes for electric current and luminous intensity is measured in candelas. You'll talk about those in physics. So, mainly you are going to be responsible for these first four: seconds, meters, kilograms, and Kelvin. So we've got our base units, and they are based on something physical, and they are one thing. They measure one thing. However, not all quantities can be measured with just a base unit. You have to use a combination of base units. This is called a derived unit. A common derived unit that you see all the time is a speed limit sign. The speed limit on Franklin Pike, between Old Hickory and Harding Place, is 55 miles an hour when you're going over the big hills. Miles per hour. Those are two different base units in the imperial system. So, since you've got two different base units, that is called a derived unit, because a derived unit is a combination. Volume, which is the amount of space that is taken up, or that an object takes up, it is measured in cubic meters. That's pretty large. But since we don't want to always have to say cubic meters or meters cubed, we can talk about a more convenient measurement, which is a liter. A liter is a cubic decimeter, so it's a little bit smaller, but it's going to be a cubic decimeter. And what that means is, think about length times width times height. So, when you're talking about length times width times height, it's something that is three-dimensional. You've got 3 meters or 3 decimeters that you're talking about right there, because it's cubic. So since it takes up space, that makes it a derived unit. So a liter is not a base unit. But we're going to be talking about density a lot today and calculating density. So density is a derived unit. And its unit is typically going to be grams per cubic centimeter, or kilograms per cubic meter, or grams per liter. grams per liter is going to be one that we'll talk a lot about later in chapter 14. But it is the amount of mass per unit of volume. So the way that I tend to write this is D equals M over V. So that's the equation, is that density is equal to mass divided by volume. What a lot of people like to do is to use what they call the triangle, and to rewrite density equals mass over volume. To rewrite it as a triangle, density, mass at the top, volume over here. And to do that, you would then say, okay, how do I get from here? How do I get from here? How do I get from here? So the way that I would rewrite this is then I can sit there and go, okay, what am I looking for? What am I trying to do? If I want to get the mass, I'm going to multiply the density and the volume. If I want to get the density, I'm going to divide mass divided by volume. And if I want to end up getting the volume, I'm going to divide mass divided by density. But we'll work all those out in just a second. I personally find it a lot easier to solve for the unknown. I know some of you really like to cross multiply and divide. If you like to cross multiply and divide, another way that you can think of this equation is D, density, divided by 1, equals mass divided by volume. So then you just plug your numbers in and solve for your unknown. So any of these equations that I've written right here, however it makes it easiest for you. So, question number 1, example A. An object has a mass of 52 grams and a volume of 74 milliliters. What is the density of the object? So, the definition of density is it's a derived unit, the mass per unit of volume. So, I'm going to go ahead and write the formula. Density equals mass divided by volume. So it's how much matter is in an object based on how much space it takes up. So I'm then going to take 52 grams, that's the mass, and a volume of 79 milliliters, that's the volume given to me in the question, and I'm going to divide 52 divided by 79. And when I do that, my answer is going to be 0.66 grams per milliliter. Because grams and milliliters don't cancel and it's a derived unit, I am going to leave that derived combination unit as the unit. Remember, you don't want any naked numbers, so your answers always have to have some sort of unit with them. Where I got the 0.66 from is because on my calculator I got 0.65822784881, so I rounded to 0.66. So, would this sink or float? The density of water, so the density of water is roughly 1.00 grams per milliliter. So right here, the density of this object is 0.66. So since that is a lower density, that means that it has less mass per unit of volume than water does, it would float. So a boat is going to float if it has a lower density than that of water. Think about how big boats float. Big boats like an aircraft carrier or a destroyer or a cruise ship, they're going to float because their mass is spread out over the very large amount of space. So, since their mass is spread out over a large amount of space, it will float on top of the water. However, if you've got a really high mass and in a small amount of volume, then things will sink. Kind of like on the movie Titanic. So right here, when a piece of aluminum, this is example number 2, When a piece of aluminum is placed in a 25 milliliter graduated cylinder that contains 10.5 milliliters of water, the water level rises to 13.5 milliliters of water. What is the mass of aluminum? The density of aluminum is 2.7 grams per milliliter. And you look at all that and you say, why do I have so many numbers? Well, let's look first at what am I looking for. So I'm looking for the mass of the aluminum. It tells me what the density of aluminum is. So I can write my equation, density equals mass over volume, and I know I'm looking for mass. I can also look at my triangle, and if I cover up the M, because that's what I'm looking for, density and volume are on the same level. So that means that to figure out the mass, to calculate the mass, I'm going to have to multiply my density times my volume. Solve for my unknown. So let's look right here and see, do I know the density? Yes, the density is given to me as 2.7 grams per milliliter. So I'm going to go ahead and put mass is equal to 2.7 grams per milliliter, and then times my volume. Well, if you look up in the question, I'm given 3 volume measurements. I'm told that I've got a 25 milliliter graduated cylinder. Well, that just tells me how big the graduated cylinder is, so I don't need to worry about that. And then it tells me that I have 10.5 milliliters of water, and when the aluminum goes into the water rises to 13.5 milliliters. So this is called water displacement. The way that I can find the volume of an irregular solid is I can see how much water it displaces. So right here, to figure out the volume, I'm going to end up doing 13.5 milliliters minus 10.5 milliliters, and I will get 3.0 milliliters. So that's my volume. And then to figure out the mass of this, I'm going to do 2.7 times 3 and get 8.1. And my units are going to be grams because milliliters cancels and it's mass. And last but not least right here, it says the density of acetic acid is 1.02 grams per milliliter. How many grams of acetic acid are in 200 milliliters of solution? So I'm looking for grams. Grams is a measurement for mass. So I'm going to use density equals mass divided by volume. Again, I'm looking for mass, so that means mass, I rearrange that, is density times volume. And then my density is 1.02 grams per milliliter. And I've got 200 milliliters of solution. Milliliters tells me that that is volume, so I'm going to multiply that. And so, if I were trying to figure out how many grams need to go in 200 milliliters of solution, I would need 204 grams. So acetic acid right there, since its density is 1.02, it would sink. So thanks for your attention. Make sure that you practice your density calculations, and I will see you next time.